with a little bit of an advertisement of an event that's going on the week before Thanksgiving. For any of you who are interested in water, this is a virtual event, but CSU is really good in terms of all the things related to water. And this is an event that's also open to students where all kinds of people from all kinds of places, government and all kinds of other places get involved in water issues in the West. So you have a link there that talks more about that. And if you're interested, it's not very expensive to join it. It's 2 days, but you don't have to go to everything, and it's all online. So next, let me give you an overview of what we're going to be doing today. We're going to start with each of the learning assistants explaining more about what would happen if you chose the major that they have chosen in terms of your next year and the kinds of classes that you would take. Then I want to just ask a quick question of all of you, and we'll do that with iClickers on how you're doing on choosing your majors. Make a couple of comments, but we want to spend most of our time in the breakout groups with the guests that we have, which are the same, mostly the same guests that we had a couple of weeks ago. So I'll explain that more when we get to it. But Keith, are you there?
Yes, I am here.
Okay, Keith, it's over to you.
Okay. Hello, everyone. I'm going to go over quickly what you'd expect to take if you were to take electrical engineering as your concentration. Ellie, you can please go through it. For freshman year, some of the classes you're expected to take are PACE, but if you had a good math foundation leaving high school, most likely you might not need to take PACE. It goes over algebra, college algebra, trigonometry, logarithms, and exponentials. And
Sure.
all that information you'll need when you go into Calc 1 and Calc 2.
Actually, are there tortillas?
Oh, someone's mic is unmuted. So if you're to take Calc 1, a lot of the information from college algebra and algebra are very useful in Calc 1. When it comes to trigonometry, things like the unit circle are things you need to remember. Also, some of your trig identities, because they make integration a lot easier. And in Calc 2, some of the same information from Calc 1 carries over, like your fundamental theory of calculus, which is very important. Your differentiation, you need to retain that information. And your basic integration. Also, trigonometry comes back in algebra, as well as logarithms and exponentials. And then you'll learn more things like parameterized curves, which are basically curves in terms of a new term that allows you to graph something that doesn't pass the vertical line test. Yeah, you can go to the next slide. Okay. And then freshman year, in terms of your electrical engineering classes, ECE102, it doesn't have any prerequisites. You can check in with your advisor in case I'm wrong there. You'll be introduced to that device on the top left. It's called an FPGA, which is a field programmable gate array. What's going to happen is they'll teach you how to program, how to draw like circuit schematics, which the software you will use, converts it into code. That allows you to prototype and also like emulate different circuits. The advantage of a FPGA is that it allows you to prototype multiple prototypes and test them and see how they work. In case you make a mistake, you don't need to send it back to a manufacturer and get like a completely new chip. You'll be introduced to the software, which is Verilog, which allows you to code, and you can use that code to represent circuits. Then you also have to take ECE103, which is a DC circuit analysis course. Here you'll be introduced to the basics of circuits. So you'll start off with DC circuits. A DC circuit is just a direct current circuit. In this class, you'll be given the Diligent package, which is a bunch of components that you'll be using in the labs. And then all you'll do is you'll build these circuits that are given to you, and then you will test out some of the theorems that you're taught in the class. And then in the lab, you get to show that these theorems are actually true. And yeah. Some of the software that you need, which is really helpful, is like MATLAB. MATLAB is used a lot in this class, especially when you have to plot different kinds of graphs. So all the MATLAB that Bert's introducing you to, you're gonna use it in this class, most likely. Go to next slide. Okay, so for physics, personally, I didn't take physics 1 because I had a credit. From what I've heard, it's pretty difficult because it's a 5-credit course. But my friends who have taken the class have told me that in order to do well in physics, you kind of need to reach out as much as possible to your instructors. And study groups are really helpful because there's some things that you might miss that your other classmates may have gotten. So when it comes to physics, I would just encourage you to take this class very seriously and to put as much time as you can, because it's 5 credits and it's really demanding. Some of the prerequisites are like Math 126, which is your, I think, logarithms and exponentials, if I'm not mistaken. Or you can take it concurrently with Math 160 or Math. And then you can go to the next slide. Okay, so for your programming classes, you only have to pick one of these, if I'm not mistaken. You can always check in with your advisor. So the CS163, which is a Java class that has no prior programming experience, and the CS164, which is a Java class with prior programming. And then there's Unix and C programming 1 and 2. With these, I haven't yet taken one of these classes, but I'm pretty sure you can pick out of which programming language you're more interested in taking. That should be it.
Okay, so next is chemical and biological engineering, and sort of just a glance forward at what you would take. Okay, so spring, if you're gonna join CBE in the spring coming up, so 2021, you can take CBE 101. And that's just sort of an introduction class, and that'll go over everything that you'll learn in this major, as well as what you can do with this degree. I believe in the spring it's taught by Dr. Riesfeld, who's really awesome. And then in the fall, it's taught by Dr. Reardon, who is really funny and really cool as well. So that's just a general class. I think you have like 2 exams the whole time. It's more just to get you interested in CBE and give you an overview of what you're doing. And as Keith was saying, so you would take your math, whether you're in PACE or if you're in Calc 1 this fall, you would move into Calc 2 and so on and so forth. Physics, if you're in Physics 1 this semester, you'd be in Physics 2 the next semester. And then chemistry, so obviously chemical and biological engineering is a very heavy chemistry and biology major. So if you're not in Chem 111 this semester, you'd have to take it next semester, and then you would move into Gen Chem 2 and then organic chemistry and so on like that. So usually the first year is just more of generals before you get to move into actual CBE courses. And then if you started all of that next, or this spring, I guess, then next fall you would be taking CBE 201 and 205. So 201 is material and energy balances. So you solve material balances, bioreactors, using chemical equations to solve larger problems. So you really like take what you learned in Gen Chem and put it to the test. And this means like flow rates and molar flow rates and things like that. So it's definitely more using just fundamental knowledge to solve larger problems. And then you also learn a couple shortcuts to make things easier. 205, this is my favorite class. I love biology. So this is like CBE 101. So it's more of a introduction class and a broad overview of how engineering can be applied to different biology like fields of study. I actually have a test in that today. So like that's going over just more of like what the CDC and the FDA, like all of the regulations that you have to follow, and also like how to graph data and things like that. So it is a numerical class as well, but also lots of really cool and fun information. And that's taught by Dr. Peebles, who is awesome. And then same thing with math, you would just move forward, take the next math class. The last math class you have to take for this major is differential equations. Physics, after physics 2, you are done, which is awesome, unless you like physics, then you can take more, but I'm not a fan. And then organic or chemistry. So this would either be Gen Chem 2 or Gen Chem 1, organic chemistry 2. And then that's the last chem course you have to take, because then your CBE finishes the chemistry with physical chemistry, which is also known as PChem. Okay, so why I chose CBE. So CBE, I think, is the engineering major with the most electives you can choose from, and they have such a huge variety. So last year I took radiation biology, and I looked a couple more up. You can take astrophysics, plant ecology, you can take mechanical engineering courses. I'm sure you could take some ECE as well, which is electrical. And if you look up just CBE curriculum electives, you will see just, I think like maybe even 100 classes you could take for credit. And that really allows you to tailor the major to what you want and sort of direct it to what you want to study, which I think is incredible. So I personally focus in more of the biology side. So I take radiation biology, cancer biology, but you could change that and take like bioreactor studies and all these other things. So there's a wide variety. And then you'll get a deep knowledge of both chemistry and biology, and then mixed with like physics, math, and all that things to get engineering. So you can really go into any field you want. Some examples like the prosthetic industry, the pharmaceuticals, oil, food. There's just so many. So really anything you can think of, CBE would apply.
All right, environmental engineering. All right, most of your first year and first semester of your second year, they're gonna be core classes. And core classes are your math classes, whether it be PACE or Calc 1 and Calc 2, or your next math class. And then your general like physics and chemistry credits. Environmental engineers don't have to take physics 2. So if you're not a fan of physics, I am not a fan of physics at all. That's really nice. And your highest chemistry class, I believe, is Chem 245, which is organic chemistry. And then you will also take some AUCCs of your choice just to fill in those extra credits while you choose your major. And once you start your second semester of your freshman year and you choose environmental engineering, you will be able to take Civ 103, which is just a general overview of civil and environmental engineering. And most of your classes, actually I think all of them, will be Civ classes. So that means they're just civil engineering. And most of your curriculum will overlap with the civil engineering curriculum until you get into your technical electives that you take junior and senior year. And in Civ 103, you do some field work. I worked with GIS, and that was really interesting. I like that a lot. And you'll just get a broad overview of what environmental engineering is. When I took this class, they split it into sections. One section was civil engineering and one section was environmental engineering. I don't know if they're going to keep doing that, because last year when I took it, it was just a test run, but I found that incredibly helpful to just tailor my interests. And then after Civ 103, you'll take Civ 202, which is basically just a class teaching you how to use. Civ is a really Excel heavy degree, which is really good if you like Excel. Yeah, Civ 202 just teaches you how to use Excel and how to code within it. And then when you take Civ 202, you'll probably take Civ 260 with it. And Civ 260 is statics, which is basically the physics of objects that don't move. And I promise it's more interesting than it sounds. And then after statics, you'll take dynamics, and then solids, and then et cetera, et cetera. And then I chose environmental engineering because I am a person who is extremely passionate in like climate change and stuff to reverse that. You can do a lot with this degree, and there are many technical electives that will help you choose what to tailor your degree towards. You can do stuff like sustainable design, or you can do like ecological engineering or water engineering. And a big focus of this major is water. So if you guys are interested in water, it's a really good path to go down. You can also take international development and then sustainable water and waste management, like I just said. And there are tons more that you can look up if you're interested.
Okay, so next is civil engineering. Okay, so it's the same exact classes as you do with environmental engineering, but I guess like with Civ 103, it's kind of more focused on the civil components of it. Some of the things that I remember from it was we did AutoCAD, GIS, some like land surveying labs, and then my year at least, we did do an Engineers Without Borders project also. I don't know if they still do that. And then the following year in the fall, we have statics, which is just kind of like structural analysis, but it's like introductory physics without motion, but it is more interesting than it sounds. And then Civ 202, which is all it is Excel, coding within Excel, organizing. You kind of it makes you really, really like advanced proficiency with Excel. So it's helpful for the real world. Maya, do you want to?
So with civil engineering, you're going to have to go up to Gen Chem 2. We take no OChem, and then you have to go all the way through differential equations for math. Only physics 1 is required, but you do end up taking statics and dynamics, which are kind of like extension courses off of physics, statics being that stationary side of physics. And so these you'll probably take within your first 2 years. And then once you get into like your second semester, sophomore year, and your junior year, you'll have more civil specific classes. So a big thing that civil engineers do is they work on water purification infrastructure, and then like soil as well. So if you're interested in any of those things, this is definitely the major for you. Another thing is that civil engineers are needed all over the world, as like infrastructure and water purification is becoming more prevalent kind of everywhere. And with that, a lot of civil engineers spend time working outside in the field more than other engineers do. So I hope this helps you guys decide.
Yeah, thanks all of you. What I'm going to do now is cover mechanical engineering, and I'm going to switch presenters as well because there's a couple of things here that are live that I want to go through in that way. So this is the whole map, and the reason I'm showing you the entire map of the 4 years is because I want to make a couple of comments related to the big picture and how it fits for many different majors. So first off, in the upper left, are the sequence that we've been talking about for pretty much every major, where you're going through 4 semesters of math, either 1 or 2 semesters of physics, as well as chemistry. And that's the same for mechanical engineering as well. Then I have check marks on courses that actually overlap with civil engineering, and in many cases also overlap with environmental engineering. So there's a lot of places where if you go into mechanical engineering, you'll be with civil and environmental engineering students also. The interesting piece for mechanical engineers that's different is the area that I've just put in the box there, and I want to go through that in more detail. So that box is shown here. And first semester freshman mechanical engineering students take Mech 103, you don't need to take that because Engineering 101 is a substitute for that. The two parallel in a lot of ways, just like they do for the introductory civil and the introductory environmental engineering courses. What that's followed with is MEC 105, which is more numerical methods for problem solving. So it is more of the kind of MATLAB that we're doing in class now. And it's basically a whole semester of using those kinds of calculations and those kinds of tools. Once you've taken that, then in the first semester of your sophomore year, you'll be taking a class in 3D modeling, and you'll be using a package called SolidWorks, which is more powerful than SpaceClaim. Then MEC 200 is also a very interesting class because this is where mechanical engineers learn how things are made. So it's basically called manufacturing processes. It has a lecture component, but it also has a lab component where you actually are in a machine shop and you actually have to fabricate different parts. So that gives an overview of the kinds of classes you would take. Why would one study mechanical engineering? Well, I think that there are 4 categories that are worth talking about. One is all of you who are interested in engines or manufacturing and things of this nature. That's where it is. That's really in mechanical engineering. The next major area that you might not be thinking about is materials oriented. So that's things like, how do you make solar?
Forgot I volunteered to.
The next area we want to talk about is biomedical related.
So sad.
Somebody needs to mute. And related to biomedical engineering, it's things like prosthetics.
That's true. That is what's weird, is that they didn't get eaten.
Somebody needs to mute.
Oh.
And then the other reason you might take mechanical engineering is that it's an engineering degree for people who want to get an engineering degree, but don't necessarily want a job that is 100% engineering. So it's very good for sales engineering. It's very good for combining business with engineering, various kinds of management roles, medicine, law, and other fields like that. So that just gives you an overview of all those fields. Now I have a quick iClicker question that I want to ask all of you, which we've been asking throughout this month, which is kind of pick your majors month. And in particular, what I'd like to have you do is update what your current situation is with regard to where you are on picking your major. So we want to try to get everybody up to level A, which means you've declared your major. Below that is B, where you're certain, but you still need to work out how to declare, or you still need to declare. C, which means you need more information, but you've got it reasonably well worked out. And D, where you're totally unsure. So go ahead and let me know what those results are, and then I'll share that here in a second to see how much progress we're making. And then we'll switch over to our guests. So one more, just very quickly, let me get all the rest of your responses. Okay, let's look at those results. And what we're seeing is that category A, which was 3 last time, is now 7. Category B, which was 17, is now 24. And there's 13 students who are still in categories where they need more information or are totally unsure. And that's very similar to what I saw in the homework assignment. And what I want to say in that regard is there are 8 students that I identified when you submitted your homework last night that in your feedback, I'm going to recommend that you talk with me, and then I can steer you to some other specific folks. And also the session we're just going to do now is going to help you as well. Before we talk about this session, I wanted to point out one other thing. And if Sudesh, Mirza, or Vignesh want to explain what's going to be happening next Thursday at 6 p.m. Do any of you want to talk about the club fair?
I can go for it. So next Thursday at 6 p.m. we have this fair. It's going to be online, where we have called for different chapters and clubs coming from different engineering fields inside CSU, and they would be actually presenting, and also they'd be answering all the questions you have about different projects they work on, what's the motive of the club, and how can you join them, and things of that sort. We're also planning to have a video before, so that these videos be uploaded like a couple of days before this fair starts, so you can like watch those videos about what the clubs are about, and you can have a rough idea so that you can choose which breakout room you want to go join during the session.
So I'll give all of you more information as it becomes available. I know that's the same night that you'll be turning in stage 4 of the project, but the club fair actually takes relatively little time, and you'll be able to earn some extra credit for the class for attending that as well. So thanks for that update, and I'll let you know more as it becomes available. So now we're ready to go into our breakout rooms, and I did a little bit of reorganizing, because what Tara's field of research is really materials oriented with biomedical. So what she is particularly involved in is the making of materials that resist microbes. So when you have an implant, you sure don't want bacteria or viruses or anything else to get in that. And that's really her expertise. So I thought it made sense for Vignesh and Tara to be in that same group. For you, any questions that you have, and any of you that want to more clearly understand what the difference is between biological engineering and biomedical engineering, that's a good group to join as well. So what we want to do in our groups is introduce yourselves, have an overview by the group leader, and then make sure that you have lots of opportunity for questions and answers. And any of you that want to pop from one room to the other, just pop out of your room, let me know, and I can put you in a different one. So with that, let me put all of you in your rooms, and you should be ready to start.
Hello, Bert. It says that.
Asif?
Yeah.
Mirza, did I put you in the wrong room?
I think it's asking me to join Vignesh's breakout room. I'm going to click later.
So I need to get you in. Yeah, so let me get you in the right one. You need to be, sorry about that. You should be now able to go in the right one.
Yeah, thank you.
Okay, Bridget, you need help on something?
Sorry, go ahead.
Sorry, I was just wondering if there's a chemical and biological room or someone I could talk to.
There isn't, but there's the biomedical room. And I've got some other things that I'll follow up with you on, because there's a couple of outside people that I think you should talk with that I think will be very interesting, that are actually practicing by both biomedical and environmental, that I think will help you. So I would recommend you actually do the biomedical one this time.
Okay. Thank you.
And Tyler, I didn't get your preferences because I didn't get your homework. So could you tell me which room you want to go in?
Yeah, I'm sorry. Civil, please.
Okay.
Thank you. And then I don't know what the late work policy is, but I'll still try to get it in tonight.
It's too late.
I mean, I don't need any credit, but like.
Let me work out how to assign you. Just a second, something's not. Ah, there we go. No. I'm still working on it.
Okay.
Something that's not allowing me to assign right now. Ah, there we go. Okay, I see where I need to be. So you want to go to civil. Okay, and Ava, which room would you like to go to?
Thank you.
Ava? Ava, you're muted. I can't hear you.
I would probably like to go to the biological one.
Okay, I'll send you there now. Okay, you should be able to go to that room now. Okay, Max, where would you like to go? Hello, Max, you're muted. Max? Okay, Bridget, where would you like to go?
Yeah, could I go to the biomedical room?
Ah, I didn't get you there, huh? Where are you now?
Environmental.
Ah, yes, let me fix that.
Awesome, thank you.
Okay. You should be able to go. Keith, do you want to go to electrical?
Sure. I don't mind. I
Okay.
still have like a few questions.
Or you have questions for me?
No, just electrical.
Okay, great. I'll send you there.
Yeah. Thank you.
Jared, do you want to go to civil?
Yeah, sounds good.
Okay. Ellie, where would you like to go?
I guess I don't really have a strong preference.
I'm going to send you to biomedical.
Okay.
There you go. Max, are you there? Max, are you there? Max, you should be able to go into civil already. You should be there. Oh, no, I see. Yeah. Yep, Max, you I put you into civil. You just need to click. Okay, how was that?
It's good. I stayed for the introductions.
All right. So where would you like to go?
uh, I guess random.
Okay, you're going to electrical.
Okay.
Hey, how was that?
Good. Mirza was going through the differences between electrical versus computer science.
Okay, well, that's an important topic.
He was going right off of the questions that I think they submitted for homework.
He doesn't know the questions they submitted for homework.
Oh, he was looking at something. Maybe it was questions he wrote down.
Yeah, he's doing good then anyway. I'm going to recommend you pop into environmental
Okay.
because that has very few people in it. So I think that might be interesting for you. Hey, how was that?
It was good. He only answered 2 questions, but they were interesting ones.
Good. Yeah, well, I get the impression he's a pretty good guy to talk with. So so that's neat. So we're in
His
about a minute.
career-
I'll bring all the groups back.
Yeah, what I found interesting was his current trajectory is kind of like the after effect of my career because he's interested in stormwater management and I forecast the storms.
That's right. So the two of you need to be talking so that he knows when he needs to get busy.
I think he will be talking with atmospheric scientists at some point. He was saying he wants to go into consulting.
Yeah. No, it's you know, I think it's pretty impressive how the things that you've done relate so much to the things that the students are doing.
Yeah, that's been pretty striking for me too, is realizing how similar it actually is.
Okay, we're inviting everyone back.
All right.
All right, welcome back. I just got a couple of things to say right at the end, and then we'll be all set. All right, just a couple of things to wrap up so you know what's going to be happening here in the next week or so. You've got an assignment that's due Sunday night. We're back to learning more about MATLAB, and I also want to cover some things on fluid mechanics concepts and how that relates to what we've been doing in terms of access to clean water and water processing. And then we'll have another assignment due next Tuesday. And then the big deal is the assignment that's due next Thursday, which is project stage 4. And then during the course of next week, all 3 classes next week will be face-to-face. We'll be covering MATLAB and water on Monday and Wednesday. And then Friday, we have more guests, and that's to talk more about electronics, and in particular, some of the things that all of you should really learn about electronics. And these are students who are upper class students from electrical and computer engineering, and they do a very good job of explaining the major and a lot of the classes and how that fits as well. So that's our plan for the next week. Look forward to seeing all of you on Monday. I hope the sessions that you've just been in were very helpful. And I think if you have further things that you need help with, a lot of this now becomes more individual. So I'm hoping that all of our guests will be good with you contacting them if you have follow-up questions. And if so, I'll send their email addresses for you to be able to do that. And we'll also, I'll talk with any of you individually and find other contacts that can help you as well. So with that, that's it. I hope you all have a good weekend, and we'll see you on Monday. Bye, y'all.
Thanks, Bert.
Bye.
Thank you.
Thank you.
Thank you.
Bye.